Hello, my name is Christopher Hall, and I will be presenting for Team 4. Our topic is Tor. What is Tor? Tor is a popular, anonymous communication system that allows Internet users to access the web anonymously. Through a group of volunteer-operated servers that aids people in improving their privacy and security on the Internet. Tor disguises your identity by distributing your transactions over several places on the Internet, so no single point can link to your destination. Instead of taking a direct route from source to destination, data packets on the Tor network take a random pathway through several relays that cover your tracks, so no observer at any single point can tell where the data came from or where it's going. To create a private network pathway with Tor, the user's software or client incrementally builds a circuit of encrypted connections through relays on the network. The circuit is extended one hop at a time, and each relay along the way knows only which relay gave it data and which relay is giving the data to. No individual relay ever knows the complete path that a data packet has taken. The client negotiates a separate set of encryption keys for each hop along the circuit to ensure that each hop can't trace these connections as they pass through. A brief history. The core principle of Tor, or onion routing, was developed in the mid-1990s by United States Naval Research Laboratory employees, mathematician Paul Syverson and computer scientist Michael G. Reed and David Goldschlag, with the purpose of protecting U.S. intelligence communications online. Onion routing was further developed by DARPA in 1997. The alpha version of Tor, which was developed by Syverson and computer scientists Roger Dingledine and Nick Mathewson, was then called the Onion Routing Project, or the Tor Project for short, was launched on September 20th, 2002. Tor was publicly released 1 year later. The corresponding code for Tor was released under a free license in 2004, and the Electronic Frontier Foundation began funding its development. Then, in the end of 2006, the nonprofit Tor Project was founded and was responsible for maintaining the Tor network. From this point forward, the funding was from the U.S. government. How Tor works. Tor works by separating identification and routing. It accomplishes this by first encrypting the randomly bouncing communication through the series of network relays which are run by all the volunteers around the world. The encryption is carried out on a multi-layered approach in order to ensure perfect forward secrecy between each relay, which ensures their network location, which allows them to evade internet censorship, which relies on blocking public Tor relays. In effect, since each packet's sender and recipient's IP address is not in plain text at any hop along the pathway, anyone eavesdropping cannot directly identify both ends of the pathway. Also, the recipient only sees the last relay in the pathway and associates that with the originator of the communication, not the true source. On top of this, every packet is encrypted throughout the entire pathway, including the final hop, making eavesdropping of any hop other than the last one very futile in determining what packet is. The steps of how Tor works are as follows. First, the Tor client on the machine requests a list of Tor nodes from the assigned directory servers. With that list, it can generate a random path to the destination server. The path it selects are all encrypted and shown in red on the graphics, except the last hop from the exit node in the destination. This is all performed over TCP and is only used when the application that can support SOCs. In order to increase efficiency, the pathway is kept open for a set period of time, usually about 10 minutes. Then after that, the pathway expires and a new one is created by the client machine. By changing the pathway every 10 minutes or so, the ability to try and determine who is the originator of the traffic by analyzing the data exiting the exit node is very difficult. However, there have been ways in which this has been circumvented. For example, traffic analysis attacks, which allow the attacker to infer which nodes are being used in the relay. After the Tor client creates the pathway, the communication it can build the packet it wants to send. It does this by negotiating separate encryption keys for each hop in the circuit. This ensures that each hop cannot trace the communication as the packets pass through. Because of this setup, each relay cannot see any more than one hop in the circuit, and eavesdrops on these circuits proves to be fruitless as the connection source and destinations cannot be seen. Why use Tor? Tor protects its users against a common form of internet surveillance known as traffic analysis. This is the analysis of who's talking to whom over a public network. By knowing the source and destinations of your internet traffic, your behaviors and interests can be ascertained, and in fact monitored, restricted, or simply analyzed. This is of great concern to people who want to or even require the ability to remain anonymous. For example, if you're a reporter and you want your sources to remain completely anonymous, or if you are the source and you fear for your safety so you want to remain anonymous, or if you do not want advertisers to track what you are looking for in order to flood you with targeted offers, or if you want access to things which you feel you're unfairly blocked from. Government investigations where the source needs to remain hidden in order to ensure a successful operation, and the list goes on. What's the risk? With all things, you have to accept the good with the bad. Tor may give a voice to the voiceless. It also provides those that wish to exploit and profit from illicit activity an avenue to do so. Drugs and other illegal goods flow freely on the dark web. The most famous of these sites was the Silk Road. Silk Road was estimated to have $45 million a year in transactions at its peak. Roughly 70% of its profits came from narcotic sales, but they also sold child pornography, stolen credit cards, assassinations, and weapons of various sorts. This was the Amazon of the dark web. It is also used by hacktivist groups such as Anonymous and by terror groups such as ISIS. You cannot be completely secure and totally anonymous on the internet. Tor cannot achieve this either. You can take steps with the browser. You have different levels of privacy. You can disable common plugins such as Java, Flash, among others. Don't use peer-to-peer networks such as BitTorrent. Torrenting sends your IP to the trackers and peers, thus eliminating privacy. You can mistake a visit to a website that's currently under investigation and wind up in a legal battle you did not anticipate. Remember who is actually funding the Tor network. The FBI has built in malware into the Tor browser that allow them to track IP information of criminal targets. It is excellent to avoid marketing and corporate data collection. It is still not secure, and since it's just a modified version of Firefox, it can be exploited by malware. Thank you very much for your time, and have a good day. Tor research is being performed around the world. This is being performed by various university research teams, but the majority of the research is being performed by the Tor project. Within this research teams, what they are looking at is how to collect data and learn about the Tor network. They're analyzing Tor to solve the problems that could come up with Tor. Some of these could be performance, others could be how a vulnerability could show up within Tor. How Tor can be used as a weapon is another thing that's being looked at by the research community. And also how to defend against such attacks. If you are interested in doing any type of research on Tor, do contact the Tor project.